Hi Earthidines, in this video we're going to look at concavity and inflection. So I've got a couple of definitions here, and this notation here with a double dash means that we're differentiating twice. And so if we differentiate twice and our derivative is smaller than 0, we're concave down. And if we differentiate twice and our derivative is bigger than 0, we're concave up. And I'll explain what that means in a minute. And then we've also got this one here that at a point of inflection the double derivative is equal to 0. So let's just sketch out a sort of a graph. We'll go like, no, I'll do something more like this. Okay, so when we're talking about concave up and concave down, you can see that the bowl of this shape is pointing downwards. That's what we call concave down. And the bowl of this shape is pointing upwards. So, you know, in concave down, if you had anything in it, it would just fall out. Whereas in concave up, if you had anything in it, it would settle in the bottom. And so what this definition up here is saying is that so long as your second gradient is positive, so what that means, so long as your gradient function is slowly becoming bigger and bigger, you're going to have concave up. And then across anywhere where your gradient function is increasing, you're going to have concave up. I feel like I just said the same thing twice there. So what I'm saying is if your gradient is decreasing, it's concave down. Okay, and if your gradient is increasing, it's concave up. Okay, and then at a point of inflection, the double derivative is 0. So there is a point somewhere between those two where it changes from being concave down to concave up. So let's look at an example anyway. So this question here is asking us to find the points of inflection. So here we're going to go to the double derivative because that's what will find us the point of inflection. So let's differentiate once. So that will be 3x squared minus 12x, and then our double derivative will be 6x minus 12. And so if we're looking for the point of inflection, we can make this double derivative equal to 0 and solve it for x. So we'd have 6x equals 12, and so x equals 2. And if we're looking for a point, that means that we need to find a y value, and so we'd have to substitute this into our original equation instead of x. So let's put 2 in for our original equation. So we'd have 2 to the power 3 minus 6 times 2 to the power 2 plus 3. So that would be 8 minus 24 plus 3, so that would be negative 13. So our point of inflection would be at 2, negative 13. So that's all we have to do to find a point of inflection.